This video is going to cover section 8.5, Determinants and Cramers rule. First of all, let's review what a determinant is. You learned this yesterday in the section 8.4 video with inverses. The determinant of a 2 by 2, if it is an A, B, C, D matrix, is given by, and it can be denoted with these vertical bars, and then it's AD minus BC. So it's the product of the first diagonal and then minus the product of the other diagonal. And just, I want you to know that these vertical bars do not mean absolute value. It's a way of denoting, find the determinant of this matrix. A matrix has an inverse, remember, if AD minus BC does not equal 0. If it were to equal 0, then that matrix does not have an inverse. If you were solving a system of equations, that would mean you would have to solve the system by hand because there are either no solutions or infinite solutions. So the example that I have is 5, 6, 2, 3. So note how it's just denoted with these vertical bars, and that means to find the determinant of this matrix. And so you do the diagonal first from top left to bottom right, 5 times 3 minus 6 times 2, which is 15 minus 12, that equals 3. So yes, this matrix has an inverse, meaning it's invertible. So we've been solving systems of equations for quite a bit. You guys first learned algebraically, that's equal values, substitution, elimination, or the addition method. Then we learned how to convert a system into an augmented matrix and use what we call reduced row echelon form, or RREF, in our calculator. Then section 8.4 covered using inverses of matrices. How do you get matrix X by itself since you can't divide using matrices? And today we are going to learn how to solve a system of equation using Cramers rule. We're only going to learn Cramers rule with two variable two equation systems. You can use Cramers rule for larger systems, but we're just going to stick with the two equation two variable system. So if you have a system of equations that is ax plus by equals c, and then the second equation is similar, so these are both in standard form. What you would usually use is like your elimination or your addition method, but this would be another place where you would want to use Cramers rule. And so if your system is set up like this, then x equals the determinant of your constants in the left column and your coefficients of the y's in the right column, so the determinant of that, divided by d, which stands for another determinant we'll talk about in a minute, and then y equals the determinant of your coefficients that are in front of x go in the left column, and then your constants go in the right column. So find that determinant using the same diagonal, the top left times the bottom right minus the top right times the bottom left. And then you divide it by determinant d, and what d is the determinant of just your coefficients, so the a's and the b's. And so if that determinant doesn't equal 0, then you guys can solve the system using Cramers rule. If it were to equal 0, you couldn't solve it using Cramers rule. Once again, it would either mean that there's no solutions or infinite number of solutions, so you would have to go back to an algebraic method. So the example that I have is 5x minus 4y equals 2 and 6x minus 5y equals 1, and I want you to solve it using Cramers rule, so using the formula that you were given. So go ahead and pause the video, determine what d is first, and then if it doesn't equal 0, then you can go ahead and solve for x and solve for y. So d is the determinant of the coefficients, and so in this case it would be 5 and -5, -4 and 6. And so when you do the determinant, you have 5 times -5 minus a -4 times 6, -25 plus 24 is -1. So that's my d value. That's going to go on the bottom. This means that I can solve this system using Cramers rule. And once again, just one little thing is that order doesn't matter. If this were a word problem and you set up the equations in the opposite order, so the 6x minus 5y was on top and the 5x minus 4y was on the bottom, you would end up with the exact same determinant. So then your x value should be the determinant of your constants, so 2, 1, and then the column over to the right should be the coefficients in front of y, so -4, -5. So you end up with 2 times -5 minus a -4 times 1 over -1. and that comes out to be a negative 10 plus 4, which is negative 6. But when you divide that by negative 1, you get a positive value of 6. So that's our x value. So that's the x value of where these two lines intersect. And then the y value would be the determinant of your coefficients that are in front of x is 5, 6. And then the right column would be your constants, 2, 1. When you do the determinant, you do 5 times 1 minus 2 times 6. 5 minus 12 is a negative 7. Negative 7 over negative 1 is a positive 7. So the point of intersection is 6, 7. That's all we are going to cover today, is just the front side of the note sheet. So go ahead and start the solving systems using inverses and Cramer's rule worksheet. It's only problems 1 through 3, and you will do the other problems tomorrow after we've completed Cramer's rule and determinants of 3 by 3 matrices. Have a good day.